can't go 3 hours.
Well, or it just ends when it ends on the video. So, okay, first things first, just to remind you again of the overview, there are 4 chapters that you should be looking at. Chapter 2, 3, 5, and 6. And I don't want to just regurgitate what's already in print in the review packet. You guys can read that. That's not a problem. Just to give you a rough idea, the pigeonhole principle, we did that basically just for 1 week at the beginning. So that's not going to be a big part of the test, but maybe it's enough of the test that you should definitely make sure you review it. Maybe 15% of the questions, maybe. This is just an approximation. I don't even know. I have not written the test yet. I will wait till the very last minute. Chapter 5 on the binomial coefficients, the multinomial theorem, the binomial theorem, Pascal's formula, some of those kind of theoretical things, combinatorial proofs. This might be more in the line of, I don't know, 25%. And it could end up being a little more than that. I don't even know exactly. But my main point is that the majority of what you're going to need to be able to do is the counting problems. And we started that in chapter 2 with things like permutations and combinations, stars and bars, that sort of thing. But then we came back to it in chapter 6 and we said, oh, sometimes we want to count something that is expressed as a union. And that's where the inclusion-exclusion came in. And then, of course, we looked at special cases of where we use the inclusion-exclusion principle, which is the topic of derangements and forbidden positions. So I would say quite possibly half or more than half of the midterm is just going to be counting problems. So when you look back at the quiz, for example, you'll see there's lots of counting problems there. So please practice, practice, practice on those. You want to be absolutely solid on them. It's very easy to talk yourself out of the right answer sometimes. And I don't want you guys to be, after the exam, saying, oh, I had it right, and then I erased it because I second-guessed myself and wrote something else down. So, you need to be solid enough with this way of thinking that you sort of know, well, when should I use the subtraction trick, and when should I not use it, right? And am I accidentally putting things in order when I shouldn't be, okay? Stuff like that. I'll just give you a quick example, because somebody came in last night and they pointed this out to me. Somewhere, I don't know where it is, it's in the review packet or a sample test or something. There's a question about poker cards that says, how many poker cards do not contain all 4 suits? Does that question sound familiar from somewhere? Yeah. Do not contain all 4 suits. And so the right way to think about that is to take all of the poker hands, 52, choose 5, and subtract those hands that do contain all 4 suits. Now, if a poker hand does contain all 4 suits, you have to think about, well, what does that mean as far as your 5 cards go? Well, if you have all 4 suits represented among 5 cards, then you must have gotten 2 cards from one of the suits, right? And then 1 card from each of the others. And one way to think about that is, well, there's 4 choices, or you could write that as 4, choose 1, choices for how many ways to choose which suit you're going to get 2 of. And then after that, there are 13 choose 2 ways to grab 2 cards from that 1 suit that you're going to take 2 of. And then each of the other 3 suits, there's 13 ways to pick 1 card, right? So these would be the hands that do have all 4 suits, and we subtract from the total. Agreed? And this is the correct answer. This is the correct answer, so does everybody understand it? How many poker hands do not have all 4 suits? So we take all of the poker hands and we subtract the ones that do have all 4 suits, okay? But somebody came into my office yesterday and had a totally different answer to this question. And it was kind of, so this is the correct answer. But they had kind of a neat idea. How many poker hands do not have all 4 suits, one way to think about that would be, well, that means at least one of the suits has to be just thrown away. So you'd have, so this is going to be incorrect, but it's going to sound kind of tempting. There's 4 ways to throw one of the suits in the garbage, like the spades. Now, that's not to say that you might not get all 3 of the other suits, but then the point was, just take the other 39 cards and pick 5 of them. And you might actually pick all hearts out of those 5 cards, in which case, not only are you not using all 4 suits, you are strongly not using all 4 suits. You'd only be using 1 suit in that case. But there's a flaw with this, you see. The flaw with this would be, let's say that you decide you're going to throw the spades away. That's your choice you're making right here. So then you're left with hearts, diamonds, and clubs. And in these 39, choose 5. Let's say you choose all 5 of the cards to be diamonds and clubs. I'm sorry, let's choose diamonds and hearts just to make them all red. Okay, so you threw away the spades, and then in the clubs, diamonds, and hearts, let's say you chose 5 cards and they were all diamonds and hearts. Okay? That would be one of the things that would be counted here. Right? However, what if we decided instead to throw the clubs away, and then we're left with spades, diamonds, and hearts, and let's say we choose those same 5 diamonds and hearts again. You see, this number has counted that as a different result. This number is too big. It's too big. It has counted those 2 things differently, because the first way was you threw the clubs away and then got your diamonds and hearts. The second way was you threw the spades away and then got the same diamonds and hearts. This number thinks that those were 2 different processes, and it counts them twice, even though you ended up with the same poker hand either way you did it. It sounds tempting, but really the right way to do this problem is what I said before, which is to subtract poker hands that do contain all 4 suits from the total number of poker hands that you have. You see, that's why I'm saying you have to practice a lot of these problems to get used to those kinds of subtleties. This doesn't require a huge amount of prerequisite mathematics. There's not a lot of deep, difficult, hard technical theorems here. It's a way of thinking, though, that is sometimes somewhat challenging. I mean, I still get challenged by these problems sometimes. Somebody comes in and asks me some question out of the blue that a 10-year-old could probably understand, and I still have to very carefully think about it. Why is something like this wrong and something like this was right? So keep working at it. Practice lots of examples. You obviously need to know, when am I supposed to use stars and bars versus when do I use the subtraction idea versus when do you have to break up into cases and add together cases for which you use the multiplication principle. Give yourself permission to think these problems through carefully. In other words, what I'm saying is, don't necessarily jump to the first thing that comes into your mind. You know, it very well could be right, but be sure to convince yourself this really is the right way to think about the problem. Or else talk yourself out of it if it's not the right way. So that, you know, don't just rush to the judgment and the first thing that comes into your head has to be the right thing. Also, be careful about, obviously I want things to be explained on the test. I'm not going to accept answers that are just completely devoid of an explanation. But I don't want you to go too far overboard on that you run out of time. And I know some people that was a problem on the quiz. Obviously my expectations on an exam in terms of your explanations and your write-up are not as high as they are on the homework assignments. So if you give a brief, so for example, if you're trying to explain 52 choose 5 poker hands, I don't expect that to take you, 2 minutes to explain. I expect maybe really quickly you write something down here like choose 5 cards. I mean, you could do that. Something very brief. Please don't write an essay to explain, well, why is it 52 choose 5? Okay, we kind of know these things by now. In fact, that reminds me of something on these homework papers. A lot of people, although the scores were very good, a lot of people were overdoing it in the sense that people over-explained the derangements thing. So if the correct answer to a problem is D5, the number of derangements of 5 objects, just write D5. You don't have to like figure it out in terms of factorials and do the whole rederiving the inclusion-exclusion formula that governs what D5 is. Just write D5. That's the answer. And then just put a little note here, derange 5 objects. Okay? You basically want to show me that you understand what's going on. That's really what it comes down to. So as brief of an explanation as you can get that across to me, the better. It's not that I'm trying to be nitpicky about having everything explained like a long explanation. It doesn't need to be. It just needs to be long enough to convince me that you know what's going on. Okay. All this is just a little preliminary strategies for taking the test and how to study for the test. I'm going to get into some problems. The main thing we're going to do today is practice problems about the material, and they are the problems that are in the review packet. Yesterday, we took 3 hours on this and still didn't finish the whole thing. So I may not get done with this whole sheet today, but if I don't, feel free to just read the solutions and come ask me if you have questions about them. I'll be around all night tonight. I'll be hanging out, so you guys can follow up with me later if there's anything that is not clear. The other thing is I'm not going to do these problems in order. I'm going to, there's certain things I definitely want to emphasize while we are sort of very super fresh, and some of them I think are easier than others. I'm going to focus on some of the harder ones. And some of these problems are kind of tricky, and I do that on purpose. I don't like to be that professor who showed all the easy problems in class and then asked all these really hard problems on the test. So I try very hard to write questions, show you questions here that are also challenging. So it might make you a little scared too, I don't know. Hopefully not too bad, but I'd rather do that than sort of mislead you, by just doing cakewalk problems, so, which you don't need a review session for. Questions, comments so far? Everybody good? And you all know you're going to either come a little bit before 4 o'clock, or you can come at 5:30 to take the test. Doesn't matter. Same test, same amount of time, everything's the same. Okay? And then we're going to get them graded. I hope to have it back to you by Wednesday. So it'll be really quick. Okay, I'm going to start with the problem about forbidden positions. And this is number 6 in the review packet because I think this would be worth reviewing. I'm going to write, this is a very long question to write down, so I'm going to abbreviate it. Okay, but obviously you don't have to take super lengthy notes here because you've got all this stuff typed up already that you can look at. So just take enough notes for whatever you need. So we have 5 employees, and I just gave them names here: Jack, John, Joe, Jim, and Jerry. And these guys are at a hotel, and they have to work, so they must cover 5 one-hour shifts at the desk from 8 a.m. to 1 p.m. Okay, so that's a 5-hour interval of time. We have 5 employees. Everybody has to work 1 hour. Okay, so how many ways are there to build the work schedule okay, so a lot of words here, but let's get to the meat of the question now. So Jack is unavailable from 8 to 9 and from 11 to 12. And then John is unavailable from 8 to 9 and 10 to 12. And Joe is unavailable from 11 to 12. And Jim is unavailable unavailable from 9 to 11, and Jerry is unavailable from 8 to 9 and 12 to 1. So you're trying to build this schedule for these 5 employees, and they have all these various constraints. So it's a real world problem. I'm a pure mathematician, but I also understand the importance of being grounded in reality of problems that actually come up in the real world, and this is a good one. So what kind of a question is it about?
Position.
Forbidden positions, and I think I already let that slip before we started. Could you have figured that out if I didn't tell you that?
Yes.
Yeah, you can kind of just tell the way the question's phrased. You have all these constraints, and you're going to build a grid. What size grid will this be?
5 by 5.
5 by 5. Okay, good. And so let me draw a 5 by 5 grid here. And what do I need to label for the grid? The names and the times. How do you want to do that here?
Names vertical.
Okay, does it matter whether I put, Joe, Jack, Jim, and so on the rows, or if I put the hours on the rows? Does that make a difference?
No.
Is that going to matter?
No.
Think about the symmetry of the problem. Eventually we're going to be putting, if you remember, we'll put dots on the white spaces that we don't X out. So that's a symmetrical process whether you do rows versus columns. So it actually doesn't matter, okay? Question? Just
So it might not matter, but are your R1s and R2s, and are those going to come out differently?
they
They
very
don't come out to be the same number, but
the individual R values could be different, but the final answer will have to cancel out in the same way to give you the same final answer.
okay. That's what I was struggling with because
Yeah.
I did it and then looked and compared. I was getting kind of worried because my numbers weren't coming out.
But the final answer was?
I wasn't multiplying it out because they're not supposed to.
Oh, well, when you're trying to check answers, that was the other thing I was going to say. Once you have worked out an answer to a question, sometimes you can check whether your answer is reasonable or not. Like if we solve this problem and our answer, if we do the addition and subtraction, it comes out to a negative number, then we know we made a mistake. Or if we get a number that's more than 5 factorial, which is the total number of permutations, we must have made a mistake. So it's not a bad idea. You're not going to have a calculator to work with, but if you have extra time at the end, I wouldn't do it during the middle of the test because you might have just made one little minor mistake, and if that's the case, you're not going to lose a lot of points for that, and I'd rather have you get all the other questions answered. But if you have time left over at the end, I don't usually have a lot of people walking out early of my tests, but nothing bugs me more than people walking out early, and then I grade their test. There's all kinds of little things that they could have fixed if they would have just spent a few more minutes. So I would recommend that you calculate your numbers if you have time at the end. But yeah, your actual R values could vary if you get rows and columns reversed of how I did it. So that's a good point. Yeah, check.
Will the columns and the rows always be the same on these problems? The number?
The number of columns and rows?
Yeah.
Oh, well, this one's 5 by 5. I mean, you can have a 6 by 6 or 4 by 4.
Can't it be like 5 by 6 or something?
Are we going to have problems like that?
No, well, you could in theory. Like obviously, you could have a time interval that goes from 8 to 2. But see, then I have to change the question, and I have to put somebody in a 2-hour shift to have the whole time covered. So you're really the reason that it comes out as a square shape is because you're talking about permutations of n numbers in n slots. So that's always a square size problem. So, I'm talking about, for example, derangements, right, are the number of ways of, let's say you have 5 numbers, the number of ways of putting 5 numbers in 5 slots so that no number is in its natural position. If you had 6 slots with only 5 numbers, it doesn't make sense, does it? Because you'd have to use the same number more than once. Well, then that's not a permutation. So it does need to be a square size. Now, what you might be thinking of, Lisa, is that in some of these problems, when you actually start working out the calculations, there's a whole row that doesn't have any x's in it. And those, so in fact, that's like the one on the group work that you did on, well, some of you did. If you're in my 4 o'clock class, you might want to try this example, because I didn't get a chance to let you work on it on Wednesday. My 5:30 class did work on this. And there's a row that has no x's in it, which just means that when you're calculating your R1, R2, and R3 in the forbidden positions process, you don't have to consider any of the cases where you use that row. So it's almost like you can delete it, in which case it's no longer a square size. But the problem has to start out as a square size for it to be something that we've really addressed here. I mean, I suppose I could make up a problem where
I just want to make sure we don't need to worry about that.
I wouldn't worry about it. Okay, so anyway, I'm going to just, so that I can do this the same way I did yesterday, I'm going to put the people's names on the corresponding to the rows. So Jack is in the first row, John is in the second row, Joe is in the third row, Jim is in the fourth row, and Jerry is in the fifth row. Okay? And then I'm going to put my time intervals along the columns. So the first column will be the 8 to 9 block, then the 9 to 10 block, 10 to 11, 11 to 12, and 12 to 1. Okay? And tell me what to do next. Okay, we put X's. We cross off the forbidden positions. Where are they?
In the first row, from 8 to 9, and 11 to 12.
Okay, so the first row is Jack's row, so you just look at the information about Jack. And then the second row is John. John's unavailable from 8 to 9 and from 10 to 12.
And Joe's just 11.
Joe is 11 to 12. Jim is 9 to 11. And Jerry is 8 to 9 and 12 to 1. So we have to basically choose one entry from each row and column using only the white squares that we haven't crossed off. So the way you do it is you do this by the subtraction principle. You take all of the permutations, there's n factorial of those, and you subtract the violations. And the formula for this is as follows. We talked about this last week. Just an alternating subtraction, addition, subtraction, addition. The very last term is going to be, well, it's either positive or negative. If n is odd, we want it to be subtracted. And if n is even, we want it to be added. So it's negative 1 to the n, r sub n. And then, of course, n minus n factorial, you don't really need to write that down. 0 factorial is just 1. Okay? And again, because there's addition, subtraction, if you got one of these r values wrong, you could come up with a negative number, which would not be realistic. And so you would maybe catch that if you actually worked out the calculation here. So I'm not expecting people to do that. You can leave it unsimplified, and maybe you won't have time to check your answer. If there's a mistake there, it's probably something with the r values, and if you get one little number wrong, it messes the whole thing up. I'm obviously not going to penalize you like for the entire problem if you get one of these numbers wrong. This is kind of a tricky business, as we'll review here in a second. Okay? But everybody at least needs to know the formula. This is the number of ways of solving a forbidden positions problem. So far, so good? Okay, can anybody tell me what is R1 equal to? R1 is the easy one. It's just the number of x's in the picture, which is 10, right? So that one, now actually what it would be better to do, I'm not requiring this, but it would be better to tell it to me as a collection of numbers that come from the rows. So 2 plus 3 plus 1 plus 2 plus 2 equals 10. And the reason for doing that is that if the final number is wrong, because you made a mistake, if you have no work to go with it, I can't help you, right? But if you have all the terms written out and you say, oh, they got 5 out of the 6 numbers right, and just screwed one thing up, then obviously I'm going to say to myself, oh, this person knows what they're doing. They just made a little goof with one of the numbers. So it's better to just write the whole thing out. In fact, when we do R2, what I like to do is actually, before I start finding the numbers, I like to just think about which 2 rows I'm going to be looking at. Everybody needs to, well, first of all, how many terms will there be for the R2? How do you get that? 5 choose 2, right? You're choosing 2 of the 10 rows. Everybody should not only be able to know that the number is 10 terms, you should be able to tell me what are the 10 choices. So one choice is the first and second row. Another choice is going to be the first and third row. Another choice is the first and fourth row. Another one is the first and fifth row. And then this is just like the odometer of your car. Please do this in the order where you keep the left digit at a 1 as long as you can before you go back. So now we've reached the highest number we have. So we go back to 2, 1. I'm sorry, not 2, 1, because 2, 1 is the same as 1, 2. Order doesn't matter. So we go to 2, 3, then 2, 4, then 2, 5. Then we move the left digit again. 3, 4, 3, 5, and 4, 5. Make sure you can list that kind of thing out, right? That's important to be able to do that kind of thing. And for 5 choose 2, it's really easy. I might ask you one that's a little bigger than that. Okay, so we have that, and now we have to take 10 numbers and work them out. Yeah, right?
So you want us to write that out on the too?
I'm just saying you don't have to, but I think this will help you.
Okay, and then what about the equation? Or
This one?
have to write that out as well?
It would be good to do that because, look, I'm really interested in knowing what you know. So if you write this formula down and you don't do anything else, let's say you don't do anything else, you don't draw the grid, you do nothing. All you do is, oh, it's forbidden positions problem, so I must use this formula, right? I will give you partial credit for knowing that formula. Probably not much. If you write down the formula, it might give you 1 or 2 points out of 10 just for writing that down. You may as well, you know, every point counts, right? So you can start with that. This picture is probably worth 1 or 2 points, right? Finding the R values is going to be a few more points. So this is all relevant, right? So the more you show me, the better. But I always hate it when people just like, that, oh, I don't know how to do that problem. They just go to the next one and they leave it blank. Then I can't do anything for you, right? So anyway, let's start working on these R values. This is where it's tricky. This is a little bit tricky. So R1, 2, that's going to be the first and second row. And what you're looking for are ways of choosing x's. But you can't choose 2 x's that are on top of each other, because if you choose 2 x's that are on top of each other, you're picking a configuration that wasn't a permutation to begin with, which means you would never have even put it into your original n factorial. So you shouldn't be subtracting it out now. Okay, so you basically, if you choose this x up here, and it's okay to do this as cases and say, well, I could pick this x or I could pick this x. If I pick this x, how many choices for x's in the second row? 2, right? I pick either this one or this one. On the other hand, if I pick this x, how many choices for x's do I have in the second row? 2. This one or this one, right? That adds up to 4, and that's the first of your 10 numbers you have to write down. There's a lot of work involved in these. Okay? The next one would be the first and third row. How many ways are there to choose x's in the first and the third row? Let's see, Elizabeth?
1.
Just 1, right? We have like 10 people in here or something. So everybody can do one of these. Okay. How about rows 1 and 4? Jessica, can you tell me if I do rows 1 and 4, how many ways there will be to choose x's? Yeah, in rows 1 and 4, the x's are all in different columns. So for this x, there's 2 choices. And for this x, there's 2 choices. So that's a total of 4. Okay. Fran, how about rows 1 and 5? How many ways are there to do that? 3 ways, right? When you have this kind of a pattern here, right? Then with this x, you have 1 choice. With this x, you have 2 choices. That adds up to 3. Okay, so how about rows 2 and 3? Lisa, can you tell me how many there will be in rows 2 and 3? So I have to pick this x. It helps to go to the rows that have less x's, right? And start from there. So in the third row, I only have 1 x. So I have to pick either of these 2. So that's 2. You said 2, right?
Yeah.
Yeah, 2 ways to do that. Okay. Jeff, how about rows 2 and 4? How many ways are there to pick x's in rows 2 and 4? 5. Did anybody agree with that?
Yes.
Anybody not agree with that?